Hello everyone, myself Sai Prasanna Kamkolam. Today I'm going to give a presentation on fake news detection using information retrieval techniques. So, before I start, I would like you to take a look at this image. It shows how quickly technology and communication are growing around the world. Every day, we use our phones and social media to read and share information. But along with true information, a large amount of fake or misleading information also spread online. In today's presentation, I'm going to talk about fake news detection, which is closely related to information retrieval, the process of collecting, analyzing, and filtering large amount of online information to find what is relevant and trustworthy. By combining information retrieval techniques with machine learning and natural language process, we can automatically identify and filter our fake news, helping make the online information we consume more reliable and meaningful. So this is what the overview about this project. So now let's see about the table of content that what we are going to discuss in this presentation. So we are going to see the introduction, system analysis, database description, module description, and system design, and the final conclusion. So now let's go to the introduction part. So coming to the introduction part, here I want to explain what fake news is and why it is a big problem today. Fake news can take many forms. It could be a joke shared out of the content, a complete make-up story, or a propaganda meant to influence people's opinion. The meaning of fake news has changed over time, and sometimes the term is even used to attack real point of view, which makes it harder to deal with. In this project, my aim is to create a fair algorithm that can currently identify fake news while treating real source accurately. This related to information retrieval becomes the IR system that finds trustworthy information from large dataset. Fake news detection focuses on filtering out flash and misleading content from the huge amount of online data. To do this, we need first to understand what count as fake news and then using machine learning and natural language processing to detect it. With the internet and social media spreading information instantly, misinformation spreads just as fast as it can. That is why detecting fake news is not only a technical task of classifying data, but also a social challenge about trust and collaborating in information. So let's go to the next slide. In this slide, we are going to see the system analysis. In this section, I will explain the system analysis of my project, how the fake news detection system works step by step. Like an information retrieval, where we study how data is stored, processed, and retrieved, here we look at how news articles go through different stages before being labeled as a real or fake. The process starts with collecting and cleaning the data. Similar to IR's document process, we unnecessarily words or symbols are removed to make the data clear. Next, we extract features using methods like counter vectors and TF-IDF. These IR techniques turns text into numbers that system can understand and analysis. After converting the text into numerical vectors, we use machine learning classifications to find the patterns that separate fake news from the real news. Finally, the system checks if we performing using accuracy and confusion metrics, like how an IR measures precision and recall to see how well it retrieves relevant information. Overall, this part of the project is about turning unstructured text into useful, searchable, and classifiable information, which is the main goal of the information retrieval. Now, so next, we are going to see the next slide, which is called proposed systems. In this project, I build a model using counter vector and TF-IDF vector, which are important techniques in the information retrieval. These methods turns text into numbers so the system can understand how often words appears and how important they are, similar to how search engines track documents by relevancy. Since this is a text classification task, I used machine learning algorithms like logistic regression (SVM) to convert the train test the data. I also experimented the different ways in representing the text using just headlines, full context, or both, and comparing them how the count vectors and TF-IDF affect the results. To improve the model, I removed common stop words like the, is, and convert all text to lowercase and keep only the most relevant words. This process followed the information pipeline where text is cleaned, indexed, and weighted by importance. By combining these IR-based text representations with machine learning algorithms, the model could effectively find patterns in language and detect fake news more accurately. So now slide, we are going to see about the domain description. In this slide, we are going to explain what was the domain of our project, mainly the machine learning, which is closely relevant to information retrieval. IR is about finding and ranking useful information from large collection of text, and machine learning helps by letting system learn how data automatically instead of following fixed rules. My project mainly used supervised learning, where algorithm is trained on data that already have collected answers. For example, just like in IR systems, learning which documents are relevant to a search. My model learns from news articles labels as real or fake. Once trained, it can classify new articles similar to how an IR system retrains the most relevant document from a database. This is also a semi-supervised learning which uses both labeled and unlabeled data, like how IR systems sometimes uses user feedback to improve search results. But in this project, I focused on supervised learning because it clearly links to the text features to their labels. Overall, this approach allows the model to learn patterns from existing data, just like IR systems learning to tell relevant from irrelevant information. Except here, the goal is to tell the real or the fake news. Now, in this slide, technologies description, we are going to see the technologies and the tools and the libraries which I have used in this project. The libraries that made building, testing, and analyzing the tools easier while also supporting key concept of information retrieval. I started with Anaconda Navigator, which helped me managing environment, installing libraries, and run applications easily without complex commands. It provided a stable Python setup, just like an IR system needs an organizational environment to handle large text collections. Next, I use the Matplotlib for visualizations to plot word frequency, model accuracy, and confusion matrix. In IR, visualization helps us understand document distribution and ranking. So this tool helped me clearly analyzing the model performance. Next, NumPy. NumPy was essentially for handling mathematical operation and data. Since IR system uses vector representation of text, NumPy helps me managing arrays and matrices efficiently. It also used iterative tools of iteration through dataset, which is useful for processing documentation, tokens, or term contributions, similar to looping over document terms relationships in IR. Finally, skinned learning was the main machine learning library that I used. It provided algorithms like SVM, which are also used in IR tasks such as text classifications, filtering, and ranking. Together, these tools help me link machine learning with information retrieval, making the fake news detecting process organized, measurable, and efficient. Next, coming to our database description. In this project, the dataset is very important because the model accuracy depends upon the quality and structure of the data. The data is like a small version of an information retrieval collection where each news article is like a document in a search engine box. It includes both real and fake news articles, which details like title, author, and context. This acts as a metadata similar to how IR systems use document features to improve search results. I split the data into a training set and testing set. The training set helps the model learning patterns and relationship between words and sentence, just like an IR systems. The testing set is kept separated to check how well the model works on new unseen data. This ensures the model is learning properly and not just like memorizing. Similarly to how an IR system is tested from precision and recall on new queries, by keeping this clear split, the model behaves more reliable, unbiased, and efficient, just like a good IR system. That's all about the database description. Now let's move on to the next slide. So in this, it's a terminology. Here we are seeing instance, feature, data type, and labels. In this slide, I will explain some key terms used in the machine learning. First, seeing the instance. It is a single row of a data. For example, one news article in my data set. In IR, each instant is like a document in a search engine carrying information that can be retrieved and analyzed. So next coming to the feature. Feature is an attribute and characteristic of the data. In my project, this could be an article title, author, or a word. Next, coming to a data type. Data type shows the type of information in each feature such as number, text, or library. In IR, this is likely how term is the frequency. Uh-huh. In IR, this is like how terms and their frequencies are stored in a structured format in an index. Next, coming to the label. Label is what the model trying to predict. For my project, labels are real or fake. In IR, labels are similar to relevance indicators showing whether the document is relevant or not a relevant query. So understanding these terms is very important because they form the basic of both machine learning and IR, helping the system organize, analyze, and classify information efficiently. So here next we are seeing the module description. Here we have two type of modules. One is user module and the other one is system module. In next slide we'll go and check in deeper about these two modules. So now in this slide we are going to see the user module. I'll explain what is the user model, which is the starting point of the system. Here is the user collects and uploads the data set, which includes both real and fake news articles. This is similar to how documents are generated in information retrieval before indexing. Once the data set is uploaded, the system automatically processes it, cleaning the text, removing the unnecessary symbols or stop words, and converting it to the numerical form. This step makes sure the data is properly structured, just like an IR system organization. The user no need to do any technical process because the system handles everything, preparing the data from training and testing automatically. Now, let's see what is system module. So now when looking at the system module, how they connect similar to the staging of the IR pipeline, the process starts with the data pre-processing. I check the data size, structure, and quantity using the Python tools like Pandas. I clean missing values, remove unnecessary symbols, and normalize the text, which is similar to the text normalization and tokenization in IR system. Now comes feature extraction, which is like indexing in IR. Then here I used count vectorization and TF-IDF to convert the text into normalization vector that shows how often each word appears and how important it is in the entire collection. Then I trained several classifications, logistic regression, SVM, to determine whether an article is real or fake. Once trained, I compare their performance to see which one the classic information mostly affects. Finally, I visualize the results using the confusion matrix and graphs, just like IR system using the evaluation matrix to measure accuracy and relevance. This model brings everything together from processing to classification and visualization. Now, let's see system design. So system design in this slide shows the overall design of the flow of my fake news detection system, which works mostly like with IR system. It brings every examination and cleaning the training data similar to how IR systems refine data collections before the indexing. Then I generate TF-IDF and count vectorization features which act like the weighting schemes in IR. In the training phase, I used modules like passive aggression, classification, and multinomials, which are effective for text-based relevance and classification tasking. After training, I evaluated the model accuracy and unseen data, just like IR system evaluates retains quality using the precision and recall. Finally, I saved the training model and picked files so they can be reused without retraining, similar to save an IR index for faster retraining. So this is here we can see the structure, how it is passing through step by step. So now here we are going to see the UML diagrams. So the first one is classic diagram. So when coming to the classic diagram, this slide shows which helps visualization how the main components in my system interact, similar to the architecture of an IR. There are three main classes here. We can see user, system and dataset. So the user class represents the person who collects or uploads the data. The system classes handles the IR-like function including the clean desk data. And the dataset, it shows the format, CSV format of data is being stored in here. Together, these classes shows the workflow from different collection to the classification. And also, we can see help in visualization how information flows through the entire fake news detection process. And now, next go to the next slide. Use case diagram. In use case diagram, it shows how the user and system interact similar to an IR environment. The user collects and provides the data set just like submitting document or queries. The system goes through several steps processing the data, extracting the features, classification, the articles, and visualization features. Features extraction act like indexing in IR, which classify it like retrieving the relevant results. Finally, the system calculates accuracy to relevant how well it is distinguishing the fake news from the news. Similarly to precision and recall in IR, the diagram this diagram summarizes the full workflow from user inputs to the accuracy output. So now next we are going to see the activity diagram. So in this activity diagram maps the process flow of the fake news detection system, much like an IR flow. It starts with the user collecting the data set following the pre-processing where the data is cleaned. The data is then split into training and testing sets similar to how IR systems separate indexing and query evaluation data sets. Next, feature extraction converts text into weightage vector like term weight matrix in IR. Classification then determines whether each article is real or fake, similar to ranking documents by relevancy. Finally, the model accuracy is relevant. Sorry, finally the model accuracy is evaluated to see how well it retrieves correct results. This diagram captures the full IR system flow from input to the output. Now, in the next slide, we are going to see the algorithm description. So, this slide explains the main algorithm used in this project. So, which also have a strong root in IR. Linear CVS creates an hyperlink to separate real and fake news, similar to ranking documents as relevant or non-relevant. The random forest classification uses multi-decision trees where each tree gives a vote, like combining results from different relevant models. This helps reduce bias and improve accuracy. The Naïve Bayes classification uses probability to estimate how likely an article belongs to the class. It fast and effective the large text datasets, which is why it's commonly used in both spam filtering and IR. All three algorithms help analyzing rank and classifying test efficiency, exactly what we can see similarly in IR system aims to. Final conclusion. Here in this slide, I'm going to just give the final conclusion of my project, what I have done in detail again. So this slide brings everything together from the system purpose to its boarded impact. The main goal is to detect fake news on social media by applying principles from IR and NLP. Just like IR systems retrieve the most relevant and trustworthy information, my model identifies real news from the fake news. The process includes collecting a dataset, cleaning it, extracting features, applying machine learning models, and evaluating accuracy. Similar to how an IR pipeline process indexing and evaluates the text. The innovation is texting multiple algorithms and feature extraction methods to find the most accurate model. In future, this could work in real time, like a live IR system that retrieves up-to-date results. The importance of this project lies in promoting digital awareness. Not all online information is accurate, and fake news detecting supports the same mission as IR. helping user finding reliable and relevant information. The ultimate goal is to help people make informed decision and identify misinformation earlier, making this digital world more trustworthy and responsible. Thank you.